Today in Chapter 4, we are going to take a look at 4.5 and 4.6, the structure of the atom and the introduction to the modern concept of atomic structure. So let's look at 4.5 to begin with. This is a picture of J.J. Thomson, who helped develop the structure of the atom. He postulated that the existence of electrons were possible using what are called cathode ray tubes. And he said that the atom must also contain positive particles if it contains these negative particles, and we now call those negative particles electrons. So this is a picture of a cathode ray tube, and there's a metal electrode at both ends, and there's a negative end and a positive end. So this is the source of the electrical potential, and the electrons flow throughout this glass tube, and this color that's shown depends on the gas that's in the tube. Then a little bit later, William Thomson came along. He is famous for the plum pudding model. He thought that there were positive and negative charges, and that this plum pudding, which is what this actually is here, is plum pudding, that this positive charge mass here was sprinkled throughout with electrons, and there were equal spreading out of the electrons, just like there would be plums in plum pudding, and that actually allowed for the counterbalance of the positive charge, so the overall charge was negative. There's an experiment done by Mr. Ernest Rutherford, and I'll show you his picture next, and it was called the gold foil experiment. And I'm going to spend just a moment looking at what this experiment did. So Rutherford looked at what the others had presented and said, you know, I don't know if it's a plum pudding model or not, but if I do this experiment and it is, what I expect to happen are for the rays to be sent out in equal random amounts. So this, what he did is he set up a gold foil experiment, and he used an alpha particle emitter, and he used gold foil. And his thought was, if the plum pudding model was correct, this alpha particle emitter would be able to just run through and pass through the other side without problems. And they had the screen set up that actually detected the alpha particles that went through. What they found was that there were some that actually bounced off and came back out, and they found the evidence of that on the detecting screen back this direction. So this led Rutherford to think that it was possible that Thomson wasn't correct. So here's what's going on. So the gold foil experiment, here are the gold atoms in that sheet, and the alpha particle, and they expected those to come straight through, but they saw these deflections instead. And if we look at it on a very simplified version, if the plum pudding were correct with this positive pink background and the yellow negative scattered throughout, it would go through. But what they actually saw, and these lines are showing that it would go through without hindrance, what I actually saw is that there were some weird angles of deflection, and some coming straight back out, some at odd angles, and those angles of deflection caused Rutherford to think that it was possible instead that there were not electrons floating throughout a positive charge, but actually a nuclear atom. So he said that the atom had a dense center of positive charge, and he dubbed that the nucleus, and then electrons traveled around the nucleus at very large distances, so very far away from the nucleus. And this was proposed in 1911. He also proposed that the magnitude of the proton and electron were opposite, but equal in magnitude. So same magnitude, opposite charges. So that no matter the size of a proton or an electron, they would cancel each other out. In 1932, Rutherford and Chadwick proposed that most nuclei also contain a large neutral particle, and they dubbed that the neutron. So a neutron is a slightly bigger mass than a proton, but negligible, and it has no charge at all. Like the proton was positive, electron was negative, and the neutron had no charge at all. So this leads us to the modern concept of atomic structure. So according to everything we can put together, we have electrons that help make up an atom, and they're found outside the nucleus, and they're negatively charged. That protons are found inside the nucleus, and they have a positive charge that's equal in magnitude to the charge of the electron. Size-wise, they're very different. Neutrons are also found in the nucleus. They have no charge. They have almost the identical mass of a proton, and they have no bearing on whether an atom has a positive or a negative charge. So the nucleus. The nucleus is a small area compared to the overall size of the atom, and it's very, very dense and accounts for almost all the mass of the atom. So the nucleus is just really, really packed together, where the electrons are in what are called orbitals, or probability areas outside of the nucleus, and they're a pretty good distance away relative to the size of the atom itself. This chart is from your book, and it shows the relative mass and relative charge of each of the three parts that make up the atom. Electron relative mass is 1, relative charge is -1. The proton is 1836 with a +1 charge. So notice that even though the proton is 1836 times bigger than the electron, their charges are of the same magnitude, opposite directions though. The neutron, it's 1839, so it's a little bit larger in mass than the proton, but really nothing that's going to change the way that we do our calculations, and it has no charge at all. So why do different atoms have different chemical properties? Well, the chemistry of an atom arises from its electrons. So electrons are the part that actually engage with and intermingle when atoms combine to form molecules. They're like the socialites of the atom. It's the number of electrons that really determine the chemical behavior. So if you're asked the question, what determines the chemical behavior of an atom, it would be the electrons. We'll talk more about this later, but while the electrons, let's move back a page, while the electrons are what determines the chemical behavior of an atom, the protons are what, I'll write this down here, protons are the personality of the atom. So, we don't change the number of protons without changing the complete atom. We can add and subtract electrons from an atom and make an ion, and we'll talk about that in the next lecture. And this is, the electrons are what's going to allow the atom and ions to interact with other atoms and ions. However, we don't change the number of protons because protons are the personality, so let's not ever forget that. Chemical behavior is related to the electrons, personality is due to the protons.